All right, welcome back. It's been a while since we had a video. Feels like a long time. We're talking now about Chapter 8, and the first section of Chapter 8 is about multiplying monomials. I think that this word monomials might be a little bit new for you, so I want you to remember that when you see that, mono means one. So here we're talking about having one term multiplied against one term. And when we think about terms, remember that we're looking at how many additions or subtractions, how many pieces to the problem. And in this case, there's only going to be one piece. So when you see that word monomial, that's what it's talking about. So now let's talk about the basics here. Multiplying monomials. The easiest type of problems that we're going to see in this chapter are the problems where we have things like x squared times x to the third. Now, you don't ever have to write this after this note, but I want you to see it so you understand what's happening. That they're telling me to do x squared. So we know that that's x times x. And then they want me to multiply that times x to the third. So that's x times one more, x. Now we learned way back in chapter 1 that if we have this situation, that our answer is going to be x to the fifth power. And it makes logical sense to you, right? If you have x squared times x to the third, we're actually going to take x and multiply it together 5 times, or x times x times x times x. You get the picture. But I don't want you to have to write this step out. I want you to understand it every time, but I don't want you to have to write it out. So we kind of have a shortcut rule that we're allowed to memorize, but it should just simply make sense to you that when we have like bases and they're being multiplied together, so the like base is x, and it's a multiplication sign in between, we can keep that base and add exponents. Same thing happens if your base is a number, right? 3 squared is 3 times 3. 3 to the third is 3 times 3 times 3. So we end up with 3 raised to the 2 plus 3 power. So 3 to the fifth power. And when we have just a number, if the exponent is 5 or smaller, you should go ahead and change it into a single number. So 3 to the fifth power is, well, let's see, what's 81 times 3? I don't know. I have to write it out. Yes, I did. 243. So again, if we have multiplication and we have like bases, then we keep the base and we add exponents. The standing rule is that if my exponent on just a number is 5 or smaller, we need to move it to its entirety, or its expanded form. So 3 to the fifth needed to become 243. However, there's an exception to that rule. If we have variables, it doesn't matter what exponent is here, you always have to change it. So if it's a number and an exponent, exponent of 5 or lower, expand. 6 or larger, leave it. Okay? Now the second rule with multiplying comes in a little bit of a different format. We call it raising a power to a power. Now look at what this is telling us to do. Visually, it tells us to take x squared and raise it to the third power. So to do that, we're going to take x squared times x squared times x squared. And if we apply the rule we just learned, and we keep the base and add the exponents, that means that we would have x to the 2 plus 2 plus 2, which is really x to the sixth power. X to the sixth power. Do you see something? Do we see a shortcut that we might be able to apply? Yes. We are going to keep the base. And actually, I think I'm going to change it. Keep all bases. You'll see why we write it that way in a few. Keep all bases and multiply all exponents. So that if we were doing this number one, 4 squared raised to the third power, instead of writing all of this stuff out, we could just say, oh, it's a power to a power. The base is 4. So that means that the exponent is going to be 2 times 3. So we have 4 to the sixth power. Because it's just a number and 6 is larger than 5, we do not need to go any further. This is an incredibly important statement here. Remember that negative x squared does not equal negative x being squared. Look at where those parentheses are at. Now I want you to test it. So this is hugely important, but now I want you to test it. Use your calculator and evaluate these two different values. I mean it. Really pause it, take a look at it. Now I asked you to check this out on your calculator. I want to show you what happened when I did it on mine. Remember the first problem here asked us to do negative 2 squared. Now when you look at this and when your calculator looks at it, it's saying take the opposite of 2 squared. That's what your calculator sees. When we're doing negative 2 being squared, it's taking negative 2 times negative 2, and that's going to give us a positive value. This is a really important piece, and it's an easy spot to lose points or not lose points, as the case really ought to be. So just be really careful with this, because I know it's on the quiz, I know it's on the test in Chapter 8. Just be prepared for it. All right, let's head back to our notes. All right, there's one more little note here, and that's about the fact that a base without an exponent has an implied exponent of 1. So just like when we see this x by itself, we think of it having a 1, an invisible 1 out in front. It also has an invisible 1 as an exponent. So x is really x to the first. Or if you wanted to take it one step further, it's really 1x to the first power. So be careful with that. Now, I think these first 3 problems are pretty easy, so pause and make sure you really understand this topic. Pause, do numbers 1, 2, 3. I think you did pretty well on these. If you have made a mistake, I think it might have happened here on number 3 that you forgot that x is really an x to the first. So make sure that you added 12 plus 18 plus 1, and you got, oh, not 20, but 21, Mrs. Sturgeon. Oh my goodness. That you got 21, not 20. 21, because I can't add. All right, let's talk about number 4. When we look at number 4, notice this is the first time we're really seeing a problem with more than one base. So when we do this, we need to just consider the x's and just consider the y's. The x's, x squared times x to the first, is going to become x to the third. Y to the third times y squared is going to become y to the fifth. Because it's all multiplied together, we can just write our answer as x to the third, y to the fifth. I think this puts you in a spot where you could probably do numbers 5, 6, 7, and you could give 8 a try, then we'll come back and talk about it. So pause the video, give them a try. So I have a feeling number 8 is probably the spot where you may have made some mistakes. So I'm going to talk all the way through it. When we look at this problem, we really have to consider the fact that we have 2 times a squared times 8 times a. And it looks really funny to write it that way, but that's really what that says. When we do that, we can multiply all of this. Remember, you're not allowed to add like terms, but you can definitely multiply anything together. So we're just going to simply use our properties, and we're going to regroup. And we can do 2 times 8, which is 16, and a squared times a. So we're going to keep that base and add our exponents. 2 plus 1 is 3. So 16a to the third. All right, I'm feeling pretty confident in you, so I think that you could probably get all the way through number 14. Again, pause it, give them a try. Now be careful. I hope when you got to number 10 and number 11, you were multiplying and not adding, because those are superpowers, or power to a power. Remember that when we have a superpower, it multiplies my strength. So superpowers, multiply. Be careful in number 13 and 14. That's what we just looked at with our calculator. This one says take the opposite. This one says to tell you This one says take negative 3 and square it. Now number 15 is kind of that tricky one. It's the reason that we wrote take every base to the power. So that when we look at number 15, we really need to say, okay, negative 2 is what number we're doing here. So we're going to take negative 2 and raise it to the second power. We're going to take m to the 5th, because that's the next base, and we're going to raise that one to the second power. And we're going to take n to the 6th, and we're going to raise that to the second power. So it's a really big superpower problem. So negative 2 to the second power is positive 4 times m to the 10th times n to the 12th. So we keep every base and we multiply every exponent. Notice in number 16 they put that negative outside. So 2 squared is 4. M to the 5th squared is m to the 10th. And n to the 6th squared is n to the 12th. All right, you got a bottom row of trig problems. I'm hoping that if anything you don't understand, you'll ask me about in class. But give them a try and check your answers. So pause the video, try 17 to 20, and I'm not going to talk about any of them in our video. I'm going to wait for you to ask about them in class.